Okay, the L'Hopital part. Now remember, for L'Hopital, we have to do some fancy things if it is an FRQ, right? We have to say that the limit produces the indeterminate form of 0 over 0 or infinity over infinity, right? Or plus and minus over plus and minus, whatever. Okay, so you take the limit of the top and the limit of the bottom, and if it produces the indeterminate form, you can take the derivative and figure out what that one is also. So let's see. If we look at this, we have, of course, infinity over infinity if you use the, right, just plugging in infinities. So that means we are able to use L'Hopital. So you take the limit as x approaches infinity of the derivative 3x squared minus 4x over the derivative 12x squared minus 1. Okay, and if we do this again, this one goes to infinity and this one goes to infinity, right? So we have to apply L'Hopital again. So we're always writing this, okay? If this is ever a FRQ, you have to do this. You have to write these down, right? It's not, these are limits. So you have to write the lim every single time you do this. Okay, so this one is once again infinity and this one is infinity. Right, so we have to write it again, the lim as x goes to infinity of 6 over 24. So now we no longer have any x's, right? So now the limit of 6/24 is 6/24, which is 1/4. Okay, so keep the lim. I saw on your papers this horrible, horrible thing where you guys were just dropping it off. That's not calculus correct. Keep the lim every single time you are taking a derivative. Okay, so how about this one? This is 1 times natural log of 1, which is 0, right? So we have 0 on top and 0 on bottom. So according to L'Hopital, we have the indeterminate form, and we can take the derivative. So this derivative is going to be a chain rule derivative, right? F times g. So f prime g plus fg prime. For the top, derivative of x is 1 times ln x plus x times derivative is 1 over x. The derivative of natural log is 1 over x. Okay, so a little bit of simplifying here gives us the lim, still lim of x approaches 1, ln x plus 1, right? X times 1 over x is 1 over 2x. So now when I plug in a 1, right, that's okay. The natural log of 1 plus 1 over 2 times 1 is 0. The natural log of 0 is 1. So this just gives me an answer of 1/2. Okay, so my limit is going to be 1/2. Okay, I'll go back. There you go. Limit is 1/2. Okay, and for our last one over here, right, when we plug in 2, we get 0 on top and 0 on bottom. So I am allowed to use L'Hopital and take the derivative. 1 over root x plus 2, that's the derivative of my root, times, I guess that one's gone, times 1, right, because that's x prime, over 1. Oh, this is not bad at all. So now I'm just going to plug in 2. 1 over root of 2 plus 2 is 1 over 4, which is once again 1/2. Okay, so make sure you're keeping the limits for every single time you have to take a derivative. Okay, whenever we have the indeterminate form, L'Hopital says that the limit is the same as when you take the derivative of your functions individually.